Hey there, welcome to a video that discusses systems of linear equations for the SAT math section. So what is a system of equations? So basically when you have more than one equation, that makes a system. But we're going to talk specifically about linear equations. And so if we look at like y equals say 2x plus 5 and y equals negative x plus 4, that would be a system of equations. If we're asked to solve the system, you're basically asked to find a point that's common to both those lines. So you can graph them and see how they look and see where they meet. You can also approach them algebraically by using substitution or elimination. So there's a lot of different ways you can go about this. We also see word problems that involve systems of linear equations as well. Something that's good to take note, if this has no solution, that would be two parallel lines. That was actually discussed in the linear equation video near the end. One solution, just two lines that touch, like that. And infinite many solutions, which basically is a single line, just two lines that are identical, they are right on top of each other. And it will be translating word problems, as I mentioned. We'll get to that in a little bit. So we'll start with something pretty basic. Um, x plus y equals 29, x plus 2y equals 12. We have to figure out what y equals. Now you could work backwards. You can test out like say choice A and see what x is and then see if that's consistent with the second equation. Or you can do substitution. X equals 29 minus y. Substitute. You're comfortable with that. So 29 plus y equals 12. Y equals negative 17. So the answer was A. Another way you could do it as well, let's actually change colors here for a bit of contrast, is you could do a process called elimination. Seems to be a little more foolproof in case if you get some nasty fractions with substitution. So what you need to do is make sure that either x or y have the same coefficients for both equations, then you can subtract equations from each other. If you do that, the x's cancel, you get negative y equals 17, y equals negative 7. So that's another way you could approach it as well. And make sure you're solving for y, not x. You read the question carefully, or sometimes it might even ask like, what is the value of x plus y or x times y? So don't get too carried away when solving these and not really pay attention to what the question is really asking for. Moving to medium level problem, calculator's allowed here. So now you're asked to translate. You're asked to make your equations from the word problem here. So you're asked, or you're told that the total fare for 2 adults and 3 kids is 14 bucks. So I'll let A be adults and C be children, or A, the cost per adult, and C, the cost per child. So hopefully you can see that the first equation would be 2A plus 3C equals 14. As you're told, 2 adults, 3 children, 14 bucks. Also, you're told that a child's fare is half adult's fare. So C equals half A, or A equals 2C if you like to get rid of fractions. Now you can probably do substitution since you already have A isolated. So it's 2 times 2C plus 3C equals 14. 7C equals 14. Cost of each child is 2. Be careful, they don't want the cost of just one child, they want the cost of a child and an adult. So an adult, of course, would be 4 bucks, double the child cost. And so it's 6 bucks. So again, just got to be really careful with the way you translate, and then solving, and then you should get the answer. Then we'll move on to a more challenging one, number 20. So let's read through this one. 2 moonflower vines are growing on a trellis in Mallory's backyard. She bought the first vine when it was 11 inches long and found it grows at a rate of 0.25 inches per day. By the way, that's going to be a slope. Hopefully you watched the video on linear equations where we talk about you can extract the slope from the problem because the slope is a rate of change. It's simply the change in y or change in x, or the change in some value, I guess in this case the change in the height of a plant, divided by time. 20 days later, she bought a second one, started at 24 inches long and has a growth of 0.125 inches per day. Okay. How many days will Mary have had the first vine when the lengths of the two vines are the same? So let's start with the first vine. Let's make an equation for that one. So now they don't tell you it's linear, but you would assume that because it's changing at a constant rate. And that's what linear equations ever are, when they change at a constant rate. And what x is the number of days. And of course, y is going to be the height of the vine. So the first vine would be y equals 0.25x plus 11. Start 11 inches, and it's going 0.25 inches per day. So after 10 days, it would gain 2.5 inches, and after it would be 13.5 inches. For the second vine. So again, we're going to use y and x, and the slope in this case is 0.125. So that's also a slope. But this is starting 20 days later. So it's x minus 20. So if it's starting on, let's say, the 22nd day, then the second vine is only going for 2 days, or you've only owned it for 2 days. And of course, plus 24. So we got ourselves two equations. Y equals 0.25x plus 11, y equals 0.125 times the quantity of x minus 20, then plus 24. So since we want them to be the same, we're going to set them equal to each other, this fashion right here, and solve for x. And that'll be the number of days they will finally have the same height. If you distribute carefully, and this is a little messy, I think that's going to be 2.5. Use a calculator. And I hope this is a calculator allowed. Yes, it is. Thank goodness. So you get 0.125x on this side. 21.5 minus 11. 125x equals 10.5. All said and done, I think you get 84. So it would take 84 days when they're finally the same height. That's when she'd have the first vine, because she had the second vine for 64 days. And you can always work it out to kind of see if it makes sense. You have 1/4 times 84 plus 11, that'd be 21, which is 32. Over here, that should have for 64 days, so it'll be 1/8 times 64 plus 24. 8 plus 24 is 32. So basically, both of each have 32 inches at the same time. So 84 days is how long you've owned the first vine. Okay, that concludes this video on system of linear equations. Goodbye.